Welcome everyone to the fourth meeting of the fall seminar series, now winter seminar series. This is put together by the Nature Conservancy and the Savanna Institute, represented by me. And we're partnering to assemble a working group on ecosystem services in agroforestry. The initial focus is on the carbon measurement monitoring, reporting and verification, MMRV, issues in agroforestry, especially as they relate to the 23, now 24 Partnership for Climate Smart Commodities projects that contain agroforestry. By working collaboratively, we hope to crowdsource ideas and promote scientific rigor across agroforestry advocates nationwide. So today we'll be hearing from Aakash from Working Trees about their phone-enabled tree carbon estimates. And this is the last of the presentations that we have on the schedule. So next month on February 2nd, we'll be meeting to get your input on lingering questions that we didn't get to, as well as next steps for the working group. So please try to make that meeting at its scheduled time if you can, since it's a lot easier to discuss things if you're in the actual meeting. Discussing things with the recording doesn't work so well. All of these past presentations have been recorded, so if you missed anything, we'll send out a link to all those recordings shortly after this meeting wraps up. And finally, I want to mention that this working group is part of a broader agroforestry coalition of working groups that includes demo farms, nurseries, market development, finance, communications, and policy. And we are also the Ecosystem Services Working Group as part of that. I want to thank the Volgenau Foundation and the Walton Family Foundation for funding this coalition and working group respectively. And with that, I will copy the Agroforestry Coalition new website into the chat in a moment here, and I'll also hand things off to Aakash, and excited to hear more from his presentation. And I think it works best to hold questions till the end. If you want to put them in the chat or write them down, I can either read them off at the end, or someone can, or else you can ask them yourself in person. All of that works. Although Aakash, feel free to override me if you have a different preference. And with that, I will hand it off to you.
Thank you, Nate. Hi, everybody. Delighted to be talking with you all today, seeing lots of familiar faces in the crowd. My name is Aakash. I'm the CEO and co-founder of Working Trees. You'll also be hearing from John, who's our chairman and co-founder at the end here. But I'm going to kick us off talking about our smartphone app for MRV. And John is going to talk a little bit about our silvopasture agroforestry program in the Eastern US. I want to thank all of the previous presenters in this series who have really set the table for this talk, so I won't spend too much time on background and context. But that said, we definitely don't have a full hour, so please pepper in your questions in the chat or in real time or at the end, whatever you want to do. So I'll kick it off here. So humor me for a second. Let's quickly talk about the importance of trees. Trees and forests are already absorbing about 30% of annual human-driven carbon emissions, so amazing benefits already. New trees can provide about a third of the mitigation required to keep future warming under 1.5 degrees C. And between agroforestry, reforestation, and avoided deforestation, we have a gigaton plus per year CO2 equivalent opportunity on our hands. And a hat tip to the recent PNC study published in Nature, which determined the global sequestration potential associated with agroforestry. I'd encourage you to check it out if you haven't already. And we all know that trees fix so much more than carbon, right? So you can think about trees increasing the water retention capacity of the soil. They can also improve water quality in riparian areas when planted as buffers. They provide habitat for biodiversity and ecosystems, some of which are critically in need of that habitat. They provide shade and cooling for both people and livestock, something that's becoming incredibly important in our increasingly warmer and warmer world, and where we're seeing the adverse effects of heat stress among both people and livestock. This is critical. They also provide climate resilience to those who are disproportionately impacted by extreme weather and really on the front lines of climate change. And by climate resilience, I mean they break wind and limit damage from storms and hurricanes and limit erosion and do so many other great things, some of which relate to economic livelihoods and production, right? Trees can provide fruits and nuts and fodder, and they can improve the bottom lines of the land stewards who manage them. So many great benefits associated with tree planting and agroforestry. Trees are also cheap. You may have seen this slide before. I stole it from Chris from the last presentation. They're the cheapest gigaton plus solution we have at our disposal for climate change. But my only problem with this chart is that it really should include agroforestry in addition to afforestation and reforestation. So I've gone ahead and made the addition myself. Trees are also scalable, right? If you look at this recent figure from the IPCC, it's showing the sequestration potential on the x-axis associated with a number of different mitigation options. And we've got, if you direct your attention towards the boxes, towards the bottom of the chart, you'll see that carbon sequestration in agriculture, as well as ecosystem restoration, have sequestration potential on par with wind and solar. So a massive opportunity here. And another recent publication from the Science Based Targets Initiative has stated that about 37% of emissions reductions needed by 2030 can happen on agricultural lands. And so we don't have any shortage of agricultural lands here on Earth. So this is a map showing the distribution of cropland and pasture. You can see how much of the land surface it occupies. It's really striking. Corresponds to about 37% of Earth's land area is made up of both crop and pasture lands. And this is an area about the size of 1 billion hectares, which is about the size of the continental United States. And if fully restored, could remove about 2/3 of all of the human emitted GHG emissions since the 1800s. So I'm beating a dead horse here, but absolutely massive potential for tree planting in both agroforestry and reforestation settings as we look to the future. However, not all good news. Right now, the scale of agroforestry and reforestation is still really small compared to deforestation. So if you look at this pie chart produced by Global Forest Watch, you'll see forest loss in purple. And you'll see that it's about double current rates of forest gain between 2000 and 2020, shown in blue. And the reason for this is really comes down to monetary incentives, right? There are more incentives to cut down trees than to plant trees right now. Of course, we need the resources that trees provide in pulp and paper and building materials. But there's good news too. And the good news is that there's increasingly more cost incentives to plant and manage trees. And these are in the form of net zero commitments from corporations and governments with climate and sustainability goals. But they need monitoring and they need assurances that their investments are resulting in actual quantifiable, tangible changes and exactly how much sequestration is resulting from their inputs. So monitoring is a challenge. Let's talk about monitoring. How do we do biomass monitoring across different scales? So here are some of the tools that we can use. And you can use instruments deployed on the ground, on UAVs, on planes, on satellites. And you might use a different tool or sensor method depending on the scale which you're interested in. Each of these methods and instruments have costs, right? Some are quite expensive. For example, terrestrial LiDAR scanning on the ground is very accurate, but it's very expensive. And this limits scalability and use in practice and practical settings. On the other hand, satellites are extremely scalable. They are mostly free. They're orbiting all the time. And this data can be used by anybody and works really well for large areas. However, you still need ground-based data to calibrate and validate those satellite-based models. And satellites don't really do a good job at some of the smaller scales that are especially relevant for agroforestry. A recent study published in Nature found that satellites are only really reliable for trees with a crown diameter of over 30 square meters. And for smaller crown diameters, satellites miss about half of the tree cover. And for our settings where we're planting new trees, it could take 10 plus years for that type of crown diameter to be reached. And we simply don't have time for that. So what we're talking about here is essentially a trade-off between accuracy and scalability, depending on your scale of investigation or area of investigation. At the The right side of this chart for the very scalable methods, you have satellites, free data, they're orbiting constantly, so very scalable, but not very accurate, right? Especially when you need data describing individual tree level properties. And I don't mean to bash satellites. You can make amazing maps like this, and they're amazing tools. They're awesome. My PhD work was all about using satellites. I worked in the remote sensing lab at NASA, but they just don't give you the individual tree properties that you need for small scale accuracy. Now, when we talk about being super accurate at small scales, on the other side of the spectrum, you actually don't need anything fancy or complicated to estimate biomass, right? And most of you have probably done this and know this all too well. But you can go out into the field and you can measure tree diameters and tree heights using a tape measure or a clinometer or a rangefinder. And then you can take those properties and put them through an allometric equation that could be species specific. And that's all you need to estimate the amount of carbon stored in the tree. But this scales pretty poorly, right? We can't measure every single tree that we're interested in, but at the same time, we need this ground-based data to calibrate and validate our models and also estimate the sequestration resulting from our practices and practice changes. So this is probably a familiar picture to many of you. I know it's a familiar picture to me. This is a fellow measuring the diameter of a tree. This is what would be used with an equation to then estimate the amount of carbon stored. And you'd rinse and repeat this for a subset of the trees in an area that you're interested in that you could then use to extrapolate across that whole area. And you can imagine this is pretty costly, right? These crews need to travel great distances. They record these manual measurements in clipboards. There's room for transcription errors. This isn't really auditable or transparent, and it's not super scalable or digital. And, I'm sure, this guy's thinking, as I have in the past when I've done this field work, surely there's got to be a better way of doing this. And so that's really the question that we were asking ourselves as we got started on working trees. Given the fact that we essentially have supercomputers in our pockets in the form of cell phones, we were asking, can we actually develop the tools that a non-expert can use to reliably estimate the amount of carbon using the equipment that they already have? And so this is what we started doing and what we've developed over the last few years. And here I'm just showing a video of the app in action. It uses augmented reality algorithms to model surfaces and measure distances. Here I'm showing the measurement of the height of a tree just behind my office. You kind of swipe up till you get to the top of the tree. We take photos of everything to be able to audit measurements later and be assured that there are no outliers or discrepancies in the data. You're also prompted to measure diameter about 1.3 meters after you've taken the height measurement. So we're measuring the diameter here. You kind of tap the screen at the left hand and the right side of the tree trunk. Again, we take a photo so we can inspect it later. And you can select the species of the tree and save your measurements. And then eventually you'll see some metadata associated with that tree measurement. You can see it on a map. You can check out the data you just collected. You can look at the latitude and longitude coordinates. You can check out the photos. There's a little section where you can write down some notes if you want that isn't shown here. And if you want to play around with this app, you can go ahead and scan this QR code, or you can go to that link and download the app from the Apple Store, or you can just search for working trees as well. Now, I'll quickly talk about what we have currently in the app and where we're going with it. So we have functionality to record the locations of tree planting projects. We have functionality to manage sample plots and organize those measurements. You just saw the ability to measure tree heights and diameters, and we just talked a little bit about some of the metadata that gets logged. We're diligently working on improvements, including fixed radius plots, an Android version that's almost done, and some more advanced 3D scanning capabilities, leveraging new advances in computer vision that I'll talk about a little bit at the end. But I'm just going to dive into each of these pillars of functionality a little bit. So as far as managing plots, we can set up organizations. We can add users and farms to those organizations. You can add plots to the farms. We found this is a nice way that people like to organize their measurements and data. And then you can sort of view the aggregate farms and trees and statistics at the organization level, at the farm level, at the user level. We can also record the locations of planted trees. So, as you're going out and doing planting, maybe you want to just bust out the phone app and click some buttons. And it's as easy as dropping pins on a map as you're walking. And we record those locations in the database as you're using the app and going through the plantings. You just saw the functionality for measuring trees. So I won't go into this too much, but that's all in there as well. So yeah, height and diameter measurements based on augmented reality algorithms, as well as the metadata that is collected immediately following those measurements. And just to get into the metadata a little bit, we collect all the GPS coordinates plus the uncertainty. We collect images of all the measurements, including the azimuth and orientation of the device, timestamps for everything, the make and models of the phones. And importantly, all of this data can be collected without network access. It gets stored locally on the phone, and then when you get back into service or when you get back home into Wi-Fi, everything gets uploaded to our cloud database. Now, we, of course, needed to validate that the measurement functionality was accurate, right? So we did a double-blind field trial in 2022 in partnership with Virginia Tech University. I see some of our collaborators on this call. And in the field trial, 4 individuals used the app to measure about 150 trees, and a different set of individuals measured the same set of trees using tape measures and rangefinders. And I'm just going to jump right into the results here. So here I'm showing a scatter plot, which shows the manually collected diameters using a tape measure on the x-axis and the app-based estimates of diameter on the y-axis. Each color is a different species, and the X's and the O's pertain to different sites. What you'll notice is a really tight correlation between the manual and app-based measurements. We have an R-squared value of about 0.95, which is excellent. A mean error of about minus 1.9 centimeters, so less than an inch of error. This corresponds to about 8.3%, and an RMSE of about 2.7 centimeters. So we are a bit biased on the conservative side, which is the right way to be wrong if you're going to be slightly wrong. But overall, we're very pleased with these results and the validation. And if you want to check out all of the gory details with this analysis, please check out our paper, which is referenced there on the bottom, published in Forests last year. And importantly, using the phone app took about half the time compared to the manual measurements. So not only is it just as accurate as using the traditional tools, it can save time and labor. And this time estimate actually doesn't include the time it takes to transcribe the measurements once you've gotten back into the office from the notebook into a spreadsheet. We can also look at the sort of uncertainty associated with the app at the level of different species. So here the table is showing the mean error associated with 4 different species: honey locust, black walnut, black locust, and loblolly pine. You'll see we're less than an inch for all of those species. And on the right, the 2 plots are histograms showing the app-based data for diameters on the black bins, and the manually collected data using tape measures for honey locust in blue and on the top plot, and for black walnut in orange on the bottom plot. And fitted distributions are shown in the same color scheme as lines. And so you'll see that we have really similar histograms, really similar distributions, but again, the app is slightly conservative relative to the manual measurements. We can also look at the uncertainty associated with different users who use the phone app to collect data, right? Because you want to make sure that different users can essentially arrive at the same answer. And this scatter plot is essentially the same as the one that you saw before. So manual diameter on the X, phone-based diameter on the Y. And here the vertical error bars show the differences between different users of the application. And you notice we still have that really tight correlation. We still have that really solid mean error of about 2 centimeters. This corresponds to a mean percent error of just over 7%, and an RMSE of 2.5 centimeters. And if we look at the distribution of diameters obtained from different users of the application and also from using the manual measurements, you'll see that essentially we converge on very similar means, regardless of who uses the app and regardless of whether they were using a phone or whether they were using a tape measure. So again, good signals that our app is working with a high degree of robustness and fidelity. Now, the height measurements are a little less impressive. And the reason for this is it gets harder and harder to detect surfaces as you get farther and farther away from the top of a tree, especially a very tall, spindly tree with a very small top. So again, the scatter plot here is showing the manual height on the x-axis, the app-based height on the y. The different colors in this case are different phone models that were used in this analysis. And we have a lower correlation here of about 0.7 R-squared value, a mean error of just over a meter, which corresponds to a mean percent error of about 17%, and an RMSE of about 2 meters. Again, I'll just emphasize here that using the height is not as critical as the diameter piece in allometric equations. And so we're actively working to improve this, but feeling reasonable about these results. And of course, the source of manual measurements in this case was not a tape measure, it was a laser rangefinder. Now, if we look at some of those different phone models and how different users are using them to measure the height, we can also conclude that different phones and different users have reasonable estimates of height across devices. So relatively similar errors across different devices and for different users. Although I would argue that user B here maybe needs a little bit more training, especially on the pixel that you see all the way to the right with some high error bars. Now, what do we do with this data that we collect using our phones, right? Well, we've just built a monitoring dashboard where somebody can log on to our website and they can view in aggregate all of the data that was collected using the phone. So on the left panel, I'm showing a bunch of sites. If you click on a site, you'll kind of zoom to this map. You can click on the number to zoom in. Each of these pins represents an individual tree that was measured using the app. If you click on a pin, you can see some of the data that was collected. You can see the estimate of the carbon stored in that tree. If you follow my mouse, you can see that we can estimate the carbon stored across all of the trees in this area. If you look at the tooltip, you can see how that was calculated, all of the equations and the references that were used. And of course, we can sub in different allometric equations for species-specific species-specific scenarios when we have them. And if you click on some of the photos, you can just view the photos of the raw measurements themselves. So encourage you to go check this out. Give us feedback, dashboard.workingtrees.com. And this is the kind of interface that we're hoping to upload all of your project's data to as we're measuring. And you can log in with your organization and you can view all the aggregate statistics and the number of trees growing and the acreage and all of that good stuff. Here's my backup slide for if the video doesn't work. Now, we also do a bit of tree counting using aerial imagery, just as an independent way to estimate mortality. So we can estimate mortality using our phone app and the sampling routine that we've designed, but we also leverage NAPE data in our plantings to just have another independent source of mortality and just be even more confident in our extrapolations. Now, what's next? What are we excited about and where are we pushing on the research side? Well, one of these areas is actually in 3D modeling. And what you're seeing here is a 3D model of a tree that I created a couple of weeks ago using about 50 photos. And of course, understanding the uncertainties and the trade-offs associated with doing work like this in comparison to just measuring heights and diameters, right? If it's 5% more accurate and it's 50% more effort, is it even worth doing? That's what we're trying to understand here, but excited about the technology nonetheless. Now, why is this important? Well, if we are able to nail this, we actually don't become reliant on allometric equations anymore, right? We can estimate woody volumes from those 3D models, and by assuming a species-specific density, we can go right to a biomass estimate by dividing that volume by a density. And some recent studies have actually shown that allometric uncertainty can be something like 30% compared to destructive sampling, which is really meaningful. And if you think about the allometric or the agroforestry context in which we're working, these trees aren't competing as much for light and for nutrients in the soil. So they tend to grow out and not up as much. And the allometric equations that are often used are developed in the forest setting. So we're almost certainly leaving carbon on the table by relying on forest-based allometric equations rather than allometric equations calibrated for agroforestry, which I think Nate and others are actually pushing on right now. And so excited to hear more about that at some point in the future. With that, I will just leave you with the thought that if you know anybody who needs to monitor their agroforestry systems outside of this group, please send them our way. We're super excited to collaborate with all of those active in the space and really excited about improving scientific rigor, improving transparency, and improving robustness across all of our efforts. So with that, I'm going to hand it over to John Foy, who's going to talk a little bit about our silvopasture project in the eastern US, or I can pause for questions related to MRV right now. Whatever folks think is best. If folks have burning questions, I'm happy to answer them while the iron's hot. I'm seeing some questions in the chat. One from Shannon. How does one handle trees that have multiple trunks at DBH within the app? Great question. We do have sort of like a toggle. It's in the sort of development phase right now. And so you can select the irregularity that the tree that is specific to the tree being measured. And then you'll get prompted for how to handle that sort of edge case. So multiple trunks is one. Sloping ground is another one. An irregular bowl at the appropriate height to measure diameter is another one. So we're thoughtful about those scenarios. If you have feedback, love to hear it. But yes. And then Shannon had another question. Does the location capture only use the integrated GPS with your iOS device, or can you toggle to a linked GNSS receiver? Great question. You can leverage a GNSS, or a higher accuracy GNSS receiver. So we've done this with Arrow GPS units, which are really fancy and really high quality. And if you want really, really high accuracy GPS, that would be a way to go. As long as it integrates with Bluetooth, it should be able to be recorded by the application. Mark asked, curious how well this tool would work in denser stands of trees. A good question, one that we're exploring. We are sort of active in the forestry context as well. So you do see some degradation of the GPS signal in closed canopies, which is notable. Also measuring height in closed canopies, irrespective of the method, whether you're using a rangefinder or the app, is just challenging. So there's really nothing we can do there. However, the diameter still works really well. We've done some field trials around the world, frankly, and been pleased with the results. So noting those limitations, we do think that this is still quite applicable in closed forest settings and denser stands of trees. Siddharth said, what is the uncertainty in estimates as canopies merge in larger trees? Now, I'm not 100% sure what this question means, but I can comment on what the sort of uncertainties might be essentially in denser stands, or as sort of the tops of canopies are merging. And it kind of speaks to what I was just saying. Again, we can collect reliable measurements, and if you're using a sampling routine like a fixed radius plot, then we're pretty much set up to do everything that a traditional forest inventory is set up to do. But if you want to get into some of those uncertainties and comparisons, we would be keen to collaborate, frankly, and probe some of those questions beyond what we've already published. So happy to chat more about that. I'm not sure if I answered your question. I wasn't 100% what you meant. That's it for the chat. Anybody else before I kick it over to John?
They can always add them at the end if the thoughts come. But thank you, Aakash. That was fantastic. As Aakash said, my name is John. I'm one of the co-founders of Working Trees. Just to provide a bit of the Working Tree story, we originally came together in graduate school because we were trying to understand why more trees aren't being planted, despite the fact that they show up in newspaper articles all the time. Tree planting here, tree planting there, like so much press, why isn't it happening? And so when we were originally exploring this space, we dug in and realized that a lot of those manual measurements that Aakash showed pictures of earlier make it prohibitively expensive for normal or small size landowners to participate. So at the time, carbon projects were saying that you needed kind of at a minimum 1,000 acres to participate. In a lot of cases, 3,000 acres plus. And this group knows even in a place like the US, farms the average is under 500. And so as we dug in, the solutions that Aakash just walked us through, we really built for ourselves first as we were launching our own carbon project in the eastern half of the US, focused on supporting livestock producers and hayland owners to incorporate trees into their agricultural systems. And so to our knowledge, we've launched the very first and actually only agroforestry carbon project in the US. And that's really what I focus on, our project in the US, and we have another one in Brazil. And so I wanted to give just a couple of minutes flavor of what that looks like. So we can talk a bit about the what and why, then get into some details on eligibility, what the economics roughly look like, and then, yeah, we can go from there. So this group probably knows this, but silvopasture is the intentional and integrated tree forage livestock system. So this beautiful picture comes from Virginia Tech. So shout out to John Fike, who I saw earlier. Keep going. The reasons why producers do that: shade, fodder, and now carbon. So shade, in many cases, can support an increase in daily gain, particularly for calves. So this is the graphs here is showing a 50% increase in daily gain from a particular study from McDaniel and Rourke. Other studies, including those led by John Fike, the conclusion is essentially, even if you don't have an increase in daily gain, you don't see a decrease, despite the fact that you now have the benefits of whatever is being produced by the tree itself, whether it's timber or a different product. When it comes to fodder, you can choose your species of trees in order to produce something that is edible by your livestock. And there's a number of species you can do this with. The one that gets a lot of attention is honey locust, and they produce these edible pods. They come late in season, and they stockpile, so you can use it to displace some of your winter hay feeding. And depending on what you're using for your winter feed, it can be hugely valuable, on the order of hundreds of dollars per acre, depending on your situation. And what our program does is enable you to also get paid for the carbon stored in those trees. And so just walking through the rough numbers on the carbon side, we have standing buyers that will pay $35 to $45 per credit. And a credit pertains to 1 ton of carbon stored, essentially. 35 is if you want to get paid upfront. So you need cash now in order to get the trees in the ground. And we will pre-sell an estimated volume for how we think your trees will grow over the first 15 years. 45 is if you get paid as the trees grow over time. So instead of getting paid in year 0, once the trees are big enough to measure in year 5, you'll start getting paid. The second point I'll highlight is the total sequestration is 1 to 2 credits per acre per year. Really depends on where you are, the species you plant, how densely you plant them. But that gives you a rough sense. And so this shakes out to, after revenue share for working trees, to $25 to $70 per acre per year in carbon alone. So if we keep going, I wanted to highlight kind of who's eligible. As I already said, we operate in the eastern half of the US. So kind of there's a line that goes down the eastern Great Plains and east. We do that to identify essentially ecosystems that historically maintained at least 10% canopy coverage. In addition to that, there's some rules that come from the carbon market. So the specific land you want to put into silvopasture must be 10 years without tree cover. It also has to be a direct conversion from pasture or hayland. So can't go straight from corn soy to silvopasture. And that has to do with some concerns about indirect land use change of, if you take some corn soy out of production, is someone cutting down a forest somewhere else to produce more corn soy? And we will not work on highly organic soils. So places where you're concerned that putting in trees might actually reduce the amount of carbon in the soil themselves. So this just gives you this map just gives you a flavor of what this eligibility looks like. So this is for a farm we're working with, and in their case, I think they're planning on putting in about 5 acres of silvopasture, but they had over 20 that they could have done it with. Keep going. I kind of already talked through the payment options, but again, if you need cash now, you can get paid up front, and I can help you cover the costs of inputs and labor. If you don't need that, you can get paid over time at a higher rate. And I'll just highlight the third option. We do offer a market rate. So companies are committing to these fixed prices because they expect the prices to go up. And so we recognize some producers don't want to lock in at a guaranteed price. So we do offer market, which means as we grow, we'll try to find the best price possible for you as a producer. All right. Yeah, you'll have to click a couple times on this one. So I didn't go into all the nitty-gritty details of what the economics look like, but the general premise of silvopasture, it costs money now to get the trees in the ground, and then you regain that benefit over time. And what we are trying to do at Working Trees is help overcome some of that upfront cash barrier by enabling that upfront payment so that you can get close to zero down, particularly if you bundle it with other grants that are available on the market. And then you can realize that benefit over the lifetime of your silvopasture system. And yeah, I'd say next one. We don't have to go through all the details, but this is for a producer. This is the process they go through. The first step is always for them to submit their information on our website. So just workingtrees.com. From there, we run their eligibility check. We can connect them with technical service providers as needed. We go through the contracting process and then ultimately use our app to enroll the trees and measure them as they grow over time. So if you know anyone who's interested, or frankly, if you're just curious, submit your information on our website and you'll get a sense of what it looks like. So I think that's everything. So hopefully that gave you a few minutes to think of more questions for Aakash. But if you have any on the US program, I can also answer that too.
I have a question about the dashboard. So the idea is that you'll be able to see any site that's being monitored by Working Trees on that dashboard. Is that correct? And then second question, how will it account for measurements made over time? So let's say you plant some trees, you measure them at year 2 as part of a PCSC project. 20 years from now or 5 years from now, whatever, you want to remeasure those trees. Will you be able to go back and assess kind of new allometric equations those trees to see how they've changed over time?
Great questions, Nate. For the first question related to whether or not you can view all of the collected data on the dashboard, essentially you can view all data collected by your organization through a login, and then you can opt in to make public whatever data that you're collecting so that others can view it too. And there's obviously like privacy concerns associated with properties and things like that. So obviously we're really committed to protecting our landowners' privacy and doing right by them. So that's kind of how we have it set up by now, but definitely encourage folks to make things public so others can sort of share in the agroforestry journey. And on the time component, yeah, I just showed like a single time slice right now, but eventually I think we will have functionality for like a time slider or a drop down. We also have some prototype kind of time series, like expected sequestration over time charts that we're prototyping out there and just ironing out the final details at the moment. So yeah, the time component is definitely in focus and will be coming down the pipe.
Great, thanks. I'll bounce a question to John too. How frequently are you seeing the highly organic soils? How much does that come up?
super rare. I mean, we've had in our pipeline, we've probably had 350,000 acres of interest, and we've probably had under 1,000 acres. But I bring it up just not to not surprise people.
They seem to be in Florida and Minnesota for whatever reason.
Those darn histosols. Also, I want to invite anyone who has questions to either put them in the chat. You're also welcome to take yourself off mute and ask them in person. That works as well.
And as a final plug, if anybody's interested in collaborating or working with us, we would love to add you and your organization to the list of the partners that you see below, and love to hear about your needs and your use cases. We actually do have a question. I think I'll let you take it, John, related to tree protection.
Yeah, the secret, well, maybe it's not so secret to Amanda, but the secret hardest part of the entire project is how do you keep the trees protected from cattle. And so one quick word of context on our program is ultimately we built our project to be very flexible. So we are not prescriptive in terms of design or species or tree protection to for and with our producers, because ultimately they're the ones who know how trees solve their problems best, and they're the ones who will be the ones managing these systems. So with that caveat, I can express what we have seen in terms of what folks are doing. And I think to simplify it, you can kind of bucket it into a few different categories. First is on a spectrum. So for the most tree protection, which we see quite often, particularly for smaller farms, is a tree tube with polywire, so electric fence. And so that way you have the double protection. The trees get up above the, usually it's like a 6-foot tree tube, and there's pretty high survival rates with that. So some of our partners say 90% survival. Middle of the road, our folks are doing just polywire, including sometimes not even electrified. When you do that, you usually expect lower survival rates, like so maybe 50%. But tree tubes are expensive, far more than the seedling themselves. So some folks have just opted for that 50% survival. Then on the extreme end, which is less relevant in the US, actually, we haven't seen it, but happens in Brazil, is you take the pasture out of production. And so you cycle your cattle elsewhere. And then once the trees are big enough, which in Brazil can be as early as 18 months, then you can cycle back in. So yeah, I hope that answered your question, Amanda, but great question.
And I see another one from Siddharth related to the Android version of the app. That is really close. It's just being reviewed by the Play Store right now. So hopefully next week, but these things can sometimes get delayed. We do have a version that I can distribute to you. That's kind of a more beta version that, I'll just send you like a zip file and you can download it. So if you're eager to play around, happy to do that. Just send me an email and I can send you the latest build.
So it seems like your carbon market part of the project is pretty focused on silvopasture by addition. A lot of the practices that are encompassed by all of these different projects in these PCSC grants, some of them include silvopasture by addition, but also they include a lot of other things. Can you speak to, can they still use working trees to monitor the carbon on their site? What does that mean for future integrating with carbon markets, or not? But at the very least, can they still use working trees to monitor carbon?
I'll give a quick answer and then John can add any color. I think you can use working trees whenever you need to measure trees. whether it is for carbon, for different types of agroforestry systems, alley cropping, buffers, breaks, forests, whatever it is, we have a tree measurement tool that works for measuring trees. Now, if you want to obtain carbon revenue from working trees, the rules are such that, well, the way that we've set things up is we work in exclusively the silvopasture context, right? Could that change in the future? Potentially, but unfortunately right now we're just limited to serving silvopasture.
Yeah, you nailed it. Nothing to add. The only thing that, just to make very clear, is carbon is a new and exciting but very confusing space. So our app is great for measuring trees. So that'll give you the carbon stock in trees. In order to run a carbon project, what you're trying to show is what would happen if we didn't have a project, and then, okay, we had a project, what are the total carbon stocks? And so the logic is much more than just measuring trees for most projects. And so there are cases where we work with our partners to go through that journey as well. And so we can do that, but particularly for, say, silvopasture by subtraction, I think that's going to be hard to run through markets, because there isn't really a great precedent, and there's only a handful of studies on this.
Great. Well, thank you for both of your time. To everyone, please come back on February 2nd. We'll be covering any lingering questions that you still have, and also talking about next steps. So we have this coalition of agroforestry advocates across the US who are interested in ecosystem services. And I think we've just scratched the surface of what we'll be able to do together. So please come back in a little less than a month for that conversation. Thank you, Aakash and John. Thank you, everyone else, for joining, and we'll see you in a few weeks.
Thanks, everyone.